because it's like we're doing this a lot, and let's say every night we test like TPCH, DS, and so on and so forth, and it's like always the same procedure because we always start from scratch. And if we
makes sense. And the size of your database?
Minimum a terabyte.
It makes perfect sense.
Hi, Sebastian.
Hi, Nikolai.
I noticed we're recording. Is it okay? We can stop it. Actually, it's
That's
for
fine. Don't worry.
Okay. Good.
Okay. So I'm working on access to the platform, and I have just asked where Sebastian found us, and it turned out that somehow he's seen our site.
Yeah,
sounds good.
I always stalk Nikolai on Twitter.
Yeah, I'm active there actually. Yes.
And then I sneak my way in. So
I'm very active on Twitter, always complaining about two facts, like they do not support edits, and I always make typos and silly mistakes.
I know that.
Like I think 50% of my tweets were deleted before they submitted. And second, that polls support only up to 4 options. It's very low. Like
that is also
few,
super
right?
annoying, actually.
Yes. So but we all still there. It's like, why? Yeah, I don't know why. Because it's minimalistic, right? So
yeah, actually, to be completely perfectly honest, I just started like, I don't know, last year or so. I never really liked it, but somehow I'm getting slowly into it now. So so yeah.
I cannot abandon it because I have like 3,000 something followers, and this is like most of them are PostgreSQL users. I cannot leave Twitter anymore because it's interesting to me to talk to all these people, right?
Yeah. So yeah, that's how I came to database lab, basically.
I see, right, makes sense. And I've heard about Swarm64 several times, read some articles. So you're making some interesting use case for Postgres, right? So, and it's like it's quite exotic, right? So it's not everyone does, right? I know very little about it, actually. Maybe we should talk somehow separately.
I mean,
actually, yes, actually, I'm participating in quite big conference in Russia. It's right now everything is online, but once it gets back, if you have very interesting cases related to Postgres, it would be great to. We would invite you to talk at this conference. It has more than 3,000 attendees, so it's
sounds
like
good.
A big one, yeah. And you're based in Germany or where? Or in Europe?
We have like the main people. Mainly, we are in Berlin. Actually, like the headquarters are here. We have one person in Cork, Ireland. One is in Greece, and we have 2 people in Boston now.
Distributed.
Yeah.
But you're in Germany, in Berlin.
I'm in Germany, yeah.
I see.
And basically, in a nutshell, what we want to do is we want to bring like OLAP and analytics to Postgres completely. Yeah,
this is an interesting thing, definitely. Yeah, like I would.
That's why.
I would discuss this separately. It's really interesting. So
no worries. We can just pull up on this. I can show you a few slides and hopefully get you excited. We're trying to get our feet into the door as well now. It's a bit difficult because people don't use it for OLAP, they use it for transactions. So,
right. Well, I believe Citus also started with idea to use Postgres for analytics and make it shardable, right? But then they shifted to HTAP or hybrid transactional.
Yeah, HTAP. Yeah, that's also what we want to do basically.
Yes.
So yeah. But so I think I will just follow up with you on that one.
Yeah, let's do it. Definitely.
Sounds good.
Okay. So
we are ready.
Great.
To start. So Sebastian, could you share your screen?
Yeah. Browser is enough?
Yeah,
yes.
The browser should be enough.
Good, there we go.
So open postgres.ai/console, and it should work. Yeah, so you need to log in. You've used GitHub account.
Yeah, I did that with GitHub. Okay.
Yeah, so we need to go to the demo organization. So like a user can participate in multiple organizations to like group instances and check up reports in like it could be teams, it could be different companies. So it's just a matter of convenience. So we need to go to the database lab instance. Initially, it's on the left side, yeah, and select the first one and the only one. Yeah. So basically, what we see here is our demo database lab instance. It has almost 1 terabyte data size, divided in multiple databases. And what we want to do now is to actually create a clone and try to connect to it and work with the data. So let's do it. So yeah.
Just hit here.
Yeah, yeah. So we need to feel like we need to give it a name and fill database username and password. The password will not be available later, so choose.
It's not stored, right? So it's kind of like for security.
Yeah.
And also snapshots, right?
Yeah. I want to tell about. Yeah, so it's like it could be simple.
It's just for testing. So and database, you'll recognize it. It's actually a PGBench database, almost 1 terabyte size.
Yeah. So and wait a second. And another parameter that can be chosen is database state timestamp. So basically, we are making every hour we are making snapshots of production, like a kind of production in this case, and a user can select exact snapshot that he wants to use as a initial state of the database for clone.
Yeah.
And later we will introduce how to say, like PITR.
Let me extend it. Like disappeared. Interrupted by phone call. Sorry. So let me rephrase it in like more database friendly language. Do you hear me? Or okay. So we have database lab is actually it can be considered as a replica or follower or like secondary of special kind. It sits on ZFS, follows the production or any other database. Usually not directly, but it's possible to follow directly as like using streaming replication or wall shipping. But usually it's reading walls from the archive, like WallG, PGBcrest, any, right? So physical backups, and usually it lags like some seconds, sometimes minutes behind the real database server. And we use snapshots locally, ZFS snapshots every hour or every 4 hours. It depends. And you can like basically time travel here, and the speed will be amazing because usually it's like few seconds you can request database from yesterday and take it like 1 terabyte database. For example, 1 terabyte database yesterday 1 p.m. and in 10 seconds you already can connect to it. This is like the main reason to do it. Right. Okay.
Cool.
let's try.
Okay, so let's create it now.
So I just picked the top one here and then.
Yeah.
Right.
Okay.
So
that was quick.
it's not very active. I mean, nobody is working with this instance. That's why it's just 1 second. Usually when like 10, 15 people are working, it may take like 20 seconds. So there is some degradation. But if a few users, it's super fast. So that's it. That's it, actually. Yes.
Yeah. So it's ready to connect, and let's do it. We can use like any client. If you want to like keep it in a browser, you can use Cloud Beaver, for example.
Okay. This is fine. I can just.
PSQL is the best, right? You need double quotes.
We need to change DB name.
Right. I'm a bit old school at the moment.
Right. I'm the same in this matter.
Should be demo.
Should be demo. Okay.
The only exception, I don't like -d because it hit me so many times in pgbench. You know this?
Right.
Like,
you can just do this here.
In pgbench, if you use -d, you always get something bad. Okay, and that password, right?
Okay. It seems like I copied the wrong one. That looks good.
Yeah. Awesome. So yeah. So it's just let's list tables that we have, and we
with
will
plus
see that
with plus to see size with plus, right?
Okay.
It's different database because it's like a smaller one. So it's one Postgres cluster, almost 1 terabyte, and it has, I think, at least 2 user databases, 5 gigs and how many? 700.
It's actually three databases.
So, but this is awesome. So you're telling me I just cloned a complete database, and I don't know what was that, 2 seconds or so.
Yeah, exactly. So let's do some damage to the data, and for example, we can delete pgbench accounts table.
Actually, drop will take some like kind of almost 1 minute, I suppose. I'm still need to understand why, but we can truncate it. So if you just truncate, yeah, it would be much faster. Just not to lose time. Also takes time. Okay.
That's okay.
Yeah, but
2 seconds.
Okay.
Longer than cloning. Okay.
Yeah, so we can check that it's actually not available now.
No, it's empty. It's available but empty, right?
Yeah.
Cool.
Yeah, cool. And so let's imagine that we are actually sharing, like usually how it's done, like we have in company big staging server and multiple people working on it, and someone is damaged our database, and we can't work until it will be fixed. But when we have database lab, we can just ask for another full-sized clone, and it will be isolated and provisioned in seconds again. So let's create another clone and connect to the second clone and check that there, like the data and are not deleted in the new clone.
So I go back to instances, was that right?
Yeah, exactly.
Demo, create clone.
Yep.
Okay. Good.
So it's ready. Let's connect it.
It's the same except the port. If you use the same password, so it's the same.
Right. So that's in 601.
Exactly.
Yeah, so let's count rows in a PagerBench account.
Sequential scan. So it's slow because it's not empty, right? So it's not empty, definitely. We see it already, right?
Yeah, that looks good. Interesting.
Mm-hmm.
Yeah,
that's really cool.
And actually, these everything is, they sit on the same machine, so it's the same. Like we spent only once like money for disks and actually for instance as well, and they share cache. So
yeah,
if, like for example, right now you're reading from these PagerBench accounts. If you create another clone and read it from inside it, you will utilize operational system cache, and it will be fast. It will be faster. Sometimes it's a problem actually, because if you want to deal with SQL optimization, for example, you want to drop caches, and we cannot drop only globally. We're still thinking how to do it, like how to deal with this problem. But for many cases, it's a benefit, because it becomes, everything is faster, and hot data is like it's cached for everyone. And if you have, for example, 20 people which potentially may work with this kind of staging or testing environment, we can set, for example, like 8-core machine or 16-core machine, depending on the activity, and it will work good, very good. So like we already testing it intensively, like this approach, and it looks very interesting, very beneficial, I would say, saving not only money, because we do not need to spend money for disks and additional hardware. For example, on RDS you can clone, you're spending money for disk, and you need to have another instance, so another compute power as well. But also time is like, cloning in seconds means that you do not need, for on RDS you need to wait for lazy load to make it data more available, and because originally they store it on S3, and lazy load, like database is up but data is still on S3, it's super slow for first half an hour or so, depending on the data size. But here it's very fast, and cloning in few seconds means that you can iterate much faster, right? It's super slow, because we are reading 100 gigabytes. So yeah, I think you can actually check it differently. Just explain select from PagerBench accounts and see how many estimated rows, right? So
yeah, that's fine.
Yeah, or some, yeah, right. So rows are for.
Yeah, I guess there is no. Yeah, what's that here?
It's here, huh? Okay.
416 million or so.
Let's maybe also try reset command, right? You can go to the first clone, and don't reshare screen. Just go to the first clone, press reset button, and return to the first database and see. I mean, the reset is in the web interface.
Yeah, I've seen it.
That's
okay. That's really cool.
Right. Okay, we don't see it, but we know it. Yes. And let's check the first database once again. Because it's
let's just
reprovisioned, right?
Then
same
rows or something. Yeah,
that's cool. Okay. That's really awesome.
Yeah. So this is thin clones with database lab, and let's continue to another our product. Can you share the browser? Let's go to the Ask Joe page. Yep, select this one. So this is our Joe bot. It's made for SQL optimization, and under the hood is the same thin clones, but like for example, developers don't need to know how to go to the database lab they just
deal with passwords, database credentials, like
yes,
port.
yes, exactly.
Forget about it. Like we know that we just need to optimize query, and that's it.
Yeah. So basically, what we can do here is just write some query, and I will send the example one to the chat, and add the explain comment at the beginning. So basically, what will happen now is the thing clone will be created, and we will run explain for this query and gather some performance metrics and plans with execution and without execution. And also we are showing some basic recommendations on how to optimize like possibilities of how to optimize the query.
Yeah.
And
summary, right? We translate from buffers language to bytes language, because we noticed that if you tell developers to read one row, you need 100,000 buffers to deal with. It's insane. They do not have impression. If you translate to bytes, multiplying by disk page size, right, 8 KB bytes, right? If they are impressed and go to optimize sooner, like this is what we noticed. Yes.
Yeah. Okay.
Yeah, and basically it's not just like one query. It's actually a session or like a clone, and we can, for example, create indexes or change database structure here. So let's create an index. Because like we have 6CON in the plan, and we want to deal with it.
BID, right?
Okay. What did we do with BID, right?
BID, right? And you need to prepare the exec command in the beginning.
Exactly.
Have some
like
meta words.
Another.
Oh, okay.
So we have additional comments because
like this, yeah.
Yeah, like explain. Yes, you can run it. So basically, you like as a developer, I don't need to have access to the production database to work to perform SQL optimization. And with Draw, developers can't like actually read the data, get the data, because they see only performance metrics plans, but they can't like Draw
deal
don't
with raw
show
data, so only metadata, right? Only plans
exactly.
and
It's so like we can.
Technically, it's possible to fetch some values. Of course, you can do some lookups and understand that this value exists in database or not, doesn't exist in database, but you cannot download and do massive export and steal data. It's still like it's employee of company, so it's still like there is some trust, and there is also an audit log, because our customers asked us to have additional protection. Their security teams asked us, so we developed also audit log, so developers know they also everything is recorded. But this is enough to optimize on full size database. And what else? Like what else, Anatoly? Like we have plans. Plan matches production because planner settings are the same as on production by purpose, right? So structurally, it makes like cache is colder, of course, so more reads than hits, but structurally it's the same plan. We guarantee it, and actually using time travel feature, you can trace plan and compare what happened yesterday, like after release, did plans change or no? So like an interesting case. But let's see. I think what's next? See plan again, or
yeah, let's try to run the same select query again to see that the plan was actually changed. Yeah, so we see that
it was 5 gigabytes. Now it's 15 megabytes, right?
Yeah, awesome. And let's run. I will put it in chat. Let's run more complicated query to get a bigger plan. Yeah, so yeah, it's finished. Let's click on permalink. Yeah. So what we have now is here is like query optimization history. So everything that developers are working on with Draw is stored and can be like shared and found later. And like it's the same information. And here we can also visualize plans to make them more readable. You can try.
Yeah, right. Okay. Yeah. I mean, it's like daily business.
Yeah.
Cool.
So
nice. Okay.
Yeah, and the more classical Depeche one.
Yeah.
And then
it's actually
installed internally.
Like
right?
Yeah, deployed. Yeah, they're installed internally and it's
protected.
Secured.
And so on.
Yeah.
Yeah, this is really cool. Awesome.
Yeah, and you can like go to the history page to see the list of queries and navigate. So for example, you can click find similar queries and the history will show like it's not like it's like in pgstat statements, so it's actually shows groups and they can they
removes parameter values. Removes values, right? Do some hash and so on. Right.
Yeah. So I think that's it. Like we have hyper.
Yeah, we covered almost everything, and I think
it's really cool.
Thank you so much. Yeah, we also had some like questions, not only how you found us, but also what kind of database you are dealing with, and like maybe you have some use cases for such kind of technology.
Yeah, I mean, what we're currently doing, for instance, is where we have some migration projects from, let's say, MS SQL Server down to Postgres. And this like requires sometimes to simply play more around with things and
to optimize, check plans
to optimize. For instance, the last thing we did now was we had to change the collation from UTF-8 to C, saving, I don't know, I think 2 hours or so of processing time. And if that would have went wrong, basically, we would have needed to restore everything back, and something like this here would be extremely helpful for these kind of things, I guess. And the other thing is more internal testing, like especially with our new stuff, we are getting a bit away from like ingestion-based testing because we were very strong at batch ingestions, but it doesn't matter so much to us now anymore. So it is like, it would be extremely helpful to be just able to say, okay, I have this database as a basis. I want to have a new instance of it and run a benchmark on it, basically.
What kind of benchmark would it be? Because like if you want a benchmark, which is I call like macro analysis, when you want to put load on like multiple threads, it will behave differently because like ZFS behaves differently compared to Ext4. So from our experience, we came to the idea that this tool is very good for micro analysis when you have one query, you want to check plan and so on, but it's not good for macro analysis. For macro analysis, you need to repeat the same infrastructure with the same file system and and so on. So like it's if you talk about this kind of benchmarking, it's kind of different, and we have also other tools for this, but like we also played with area of macro analysis, but right now we are focusing on micro analysis, and we noticed that developers needed even more, and sometimes bad queries hurt even more than compared to bad settings, for example, bad configuration of Postgres. So is it like,
so in the benchmarks we do typically nightly runs of TPCH and TPCDS now,
right?
But we also ingest them all the time again, and this just becomes painful right now, I guess. So this would be one area.
If we talk about, I think if we talk about benchmarks which are compared, like if you compare benchmark on ZFS versus benchmark on ZFS, it again becomes interesting because you have the same like proper baseline. But if you compare the benchmark on ZFS versus X4, sometimes like reading or creation of index may take like 2 times longer. It's like normal because they behave differently.
If you would do this, it would be more important to keep the infrastructure alive, but to test on different versions of our product, basically. So everything else should stay fixed. You just iterate over the versions. Meaning we would need to create a new baseline anyways for that.
Okay, so good. And what kind of I remember Anatoly asked, but I didn't get it. What kind of size of databases? Like terabytes, 100 gigabytes, dozens terabytes?
Typically, we target now a terabyte of TPCH. We want to go higher. Let's say we target them 3, 5, or 10 terabytes, but the typical thing we do is 1 terabyte.
Okay, sounds good. Okay.
So that's very interesting, I guess.
Let's think and maybe follow up later and talk about your technology as well. I will be interested.
Yeah, sure. We can
learn
more.
I
would be happy to do so.
Good. And one more question: if you consider your client, I think you have some clients already which have large databases, right? And okay. And if yes, and if like, do you think there are some cases there for such kind of technology, like just out of curiosity?
Yeah, I think so. Also, especially where we did now the migration from MS SQL Server, I think they try to do a lot with these kind of things. Although they are a bit more high level, but there are some other interesting opportunities probably to just look into. I think this is extremely helpful, especially this like snapshot capability. And I just thought about, do you have like, so is this running on AWS here?
Right now, this is running on some on-premise data center. We just migrated from GCP to save some budgets, but it's like kind of it can be running anywhere. So like,
because I'm wondering about the performance capabilities of ZFS on AWS EBS block storage, whether that works at all.
Right. But okay, we can consider two approaches there: either EBS or local, like i3 or what's more modern instances with local NVMe. And like, since this is not production, if it somehow fails, we have fully, right now we have, it took a lot of efforts, but right now we have fully, we call it declarative provisioning. So you just define some big YAML defining how to get data, how to do snapshots and so on. So provisioning is fully automated. So if we could use local NVMe disks, and they are super fast, of course, right? Like 2 gigabytes per second, and 70,000 IOPS and so on. So like
yeah.
So I would consider first this kind of instances like i3 or I don't remember newer ones. So right, and what like let me adjust a little bit. We like since we looked at JawBot, we call it JawBot, this skill optimization bot as a last item. I would emphasize that this is just like we have database lab, and on top of it we create like we call it apps, like applications to solve some narrow particular tasks, right? Of course, database lab can be used not only for SQL optimization, but for example, we right now working on automated checks of database changes made in CI. So we call it CI observer, and this CI observer highlights dangerous logs. So it applies like alter table, create index, and so on to clone, full size clone, thin clone, which is provisioned in seconds, and applies all changes, and then prints report, right in CI prints report how long it took, what kind of activity it was, and what kind of logs observed. And depending on settings, it can mark a CI build as failed.
Okay.
So we didn't include it in demo yet, but I think in next couple of weeks it will be already also included, because it's very interesting also case to avoid bad changes. If your team is growing, lack of supervision may lead to very bad situation on production, right? So we want to protect production. And this is just two of specific examples. We know that there are many examples. We just haven't explored all of them.
Yeah.
So, okay.
That's cool.
I think,
awesome.
Yeah. Thank you so much. We'll be happy to follow up later and discuss if you have some thoughts, questions, or something like this.
Yeah, sounds good.
Okay. Thank you so much, Sebastian.
Thanks a lot for your time and for the demo.
Yeah.
Thank you so much. Bye-bye. Have a good day.
Bye.
You too. Bye.